as well as the theories which are involved in chemical kinetics, in chemical systems or chemical bondings, right? Now, in last lecture we have started MO theory. This MO theory actually derived as when atoms combines together to form the molecules. Likewise, the atomic orbitals combines together to form molecular orbitals. So the molecular orbitals actually has the shape, the characteristics of the atomic orbitals only. This is the base of MO theory. They take the shape of their atomic orbitals only, and they have different energy levels, different energy states, because after combination it can be different. Now, next theory is LCAO theory, which is linear combination of atomic orbitals theory. According to this method, due to or the molecular orbitals are formed by the linear combination of atomic orbitals. It has been said that when atomic orbitals actually collinearize with each other, at that time such kind of atomic orbitals can be combined. Okay, now let us consider the simplest case of H2 molecule, which consists of two hydrogen atoms. They can be represented as HA and HB. Now, the atomic orbitals of these atoms are represented by the wave functions. For HA, it can be written as psi A, and for HB, it can be written as psi B. Right? Now, molecular orbitals is formed by the addition of wave functions of atomic orbitals. So, it can be represented as this equation. How can we represent it? We know that we have different kinds of molecular orbitals, like bonding orbitals, non-bonding orbitals, anti-bonding orbitals, etc. So here, let's take into account, we have psi MO is equal to psi A plus psi B. This is known as equation number 1. The MO formed here is referred as bonding molecular orbital, and it lowers the energy and brings about the stability in the system. Okay, it's a bonding one. Now, because we have written here plus, right? When we have the bonding orbital, we have to write plus. Now, the molecular orbitals which are formed by the subtraction of the atomic orbitals are known as the non-bonding orbitals. How can we represent them? It can be represented as psi star M is equal to psi A minus psi B. Right? This is our equation number 2. Okay? So, psi represents the bonding orbital, while psi star represents the non-bonding orbital or anti-bonding orbital. That means with which we can't have or with which the bonds cannot be formed. Make sure to understand this. Now, let's take the example which is H2 molecule here. Right? So, for H2 molecule, you have to understand that the hydrogen molecule is formed from 1s1 atomic orbitals of two different atoms. Right? They give rise to two molecular orbitals. One is sigma 1s, another one is sigma star 1s. As we have seen that bonding orbital, non-bonding orbital. Now, the molecule has two electrons to be accommodated in these two molecular orbitals and are filled as desired by Aufbau's order of filling. Here it will follow the Aufbau's order of filling. You need to understand it properly here. Okay? Then it combines two different principles. Now, let's see that how we can represent it here. As you can see, the pink color boxes are 1s atomic orbitals. So 1 electrons are there, as the electronic configuration of hydrogen is 1s1. So you can see it here. Now, in sigma 1s you can see two different orbitals. As first, the lower energy orbitals is to be filled first. So here the bonding orbitals are filled and the bond formation occurs, that is H, single bond H. The middle orbitals show the molecular orbitals, while the yellow one is psi star 1s, which is basically the non-bonding orbitals. No electron is involved in that, and because of it, the bond formation occurs here. Okay. Now let's begin with the next one, which is types of bonds. Let's understood first that what is a bond. So, a chemical bond is defined as an electrostatic attraction that acts between two or more atoms to hold them together as a stable molecule. It's an electrostatic attraction with which two different atoms combines with each other, hold on with each other and forms a molecule. And it is required for a stabilization purpose. Like we have known, like Na plus and Cl minus, both of them combines forms a single bond. And at that time they have to be stabilized. So Na has plus 1 charge, Cl has minus 1 charge, plus 1 minus 1 becomes neutral, a stabilized molecule, right? Now let's see that which kind of bonds are there or which types of bonds are there. First one is ionic or covalent bond, electrovalent bond. Second one is covalent bond. Third one is coordinate covalent bond. Fourth one will be metallic bond. And fifth one is a hydrogen bond. Let's see them individually, that how it can be possible. Here, the ionic bond, first one we will take is ionic or electrovalent bond. So the electrostatic attraction when arises between a cation and an anion, a positive and a negative charge, it contributes or it becomes ionic bond. The compound is known as ionic compounds, right? Now, let's see the example. As you can see it in the image, A has one extra electron, B has one less electron. Here, rule of octet came into existence. It will play a very important role. So A gives its electron to B, so B fulfills itself, and here A and B, a electrovalent bond forms, ionic bond forms, and the compound formation occurs, right? Let's see the second one, which is covalent bond. The attractive force between atoms created by mutual sharing of an electron. Understood it? Mutual sharing of the electron is known as covalent bond. The compounds formed here are known as covalent compounds. In the image, as you can see, here A and B are there. A has one extra electron, B also has one extra electron. Both of them combines with each other by mutual sharing of an electron, equal sharing of an electron, and the bond formation occurs, which is known as covalent bond. It can be of single bond, it can be a double bond, it can be a triple bond. We can take the example like C single bond H. We can have C double bond C. We can have C triple bond C. So according to that, we will have different kinds of covalent bond. They are strong in nature. Now, next one is coordinate covalent bond. It is a type of covalent bond. A covalent bond in which both electrons of the shared pair come from one of the two atoms. That means single-sided sharing occurs. They are known as coordinate covalent bond. Now, the compound containing a coordinate covalent bond is known as coordinate compounds or coordinate covalent compounds. It actually depends that how it is formed, right? Now, let's take the example here. As you can see in the image, we have A and B. The electrons which are required for the bond formation is given by A here, while B just take part into it. So A gives both the electrons, coordinate covalent bond occurs, and formation of coordinate compound happens here. Now, next one is metallic bond. How it can be formed? So when a bond formation occurs between a metal and a non-metal. It forms a metallic bond, and the compounds are metallic compounds. Let's see the example here. As you can see, FeCl2, FeCl3, K2CrO4, right? These all are examples of metallic compounds or metallic bonds. Now, next one is hydrogen bond. A widely available bond, widely utilized bond is hydrogen bond. The electrostatic attraction occurs between an H atom and or covalently bonded to a highly electronegative atom is called hydrogen bond, and the bonding is known as hydrogen bonding. There are two different types are there. First one, intermolecular. Second one, intramolecular. So intermolecular forms between different molecules, two different molecules. It generally forms because of the slightly positive charge, slightly negative charge. As you can see in the image, we have HF. One bond will be formed between H and F, while another bond will be formed between one molecule F, while another molecule H. So both of them combines with each other and forms HF. Right? Here, now, let's take another example which involves intramolecular bond. Intramolecular can be possible within the same molecules, right? So as you can see in the image, we have H2O, and H2O involves both the kinds of bonds, inter while intra. Likewise NH3, both the kinds of bonds are present, inter and intra. So in this way, we can understand that how chemical bonding actually occurs. Thank you so much everyone.